do with a BIOS maybe, and also not as fast. Grub2 is also up there. It's also a bootloader. We've had some difficulties getting coreboot getting coreboot support into Grub2, but it's finally getting there. But not only bootloaders, the payload could be utilities of some sort. It could be memtest86, RAM test tool, which is also used by us developers to see that we've really configured the machine properly. Because nothing, the most difficult part of initializing hardware is getting the RAM configuration correct, and memtest will always show us if we've made some mistakes. CoreInfo is a nice small utility, has some basic system information, looks at the PCI devices. We're going to see that in the demo a bit later, I hope. And here it says Linux again, because, okay, so you can have a kernel in your firmware, but you could also put an init ramfs in the kernel, and then you can load up, I don't know, whatever applications you want to have there, as long as you have room in your flash chip. Rescue utilities, and at least a shell, a prompt that you're familiar with. Ron, the guy who started this thing, he likes to bash open firmware because of the OK prompt. I don't know if you've seen it. When an open firmware machine has a problem during boot, it stops and the prompt says OK. But in reality, things aren't really OK. So he really likes to have a Linux system and a shell that he's familiar with during the boot process, in case anything goes wrong. And I mentioned we can do applications as payloads. We can have stuff like Tint, which we'll have a look at later. It's a nice little game. Bayou is really important to mention because coreboot can really only start one payload, a single payload. But maybe that's not enough. We have a really big flash chip, so we want to stuff a whole bunch of these guys in there. Then we use Bayou to first of all pack several different payloads into one, and then we use Bayou as the coreboot payload. Bayou gives us either an interactive menu that we're going to have a look at, or you can script it to do stuff in sequence and have some control over the boot process. Both Tint and Bayou and CoreInfo are realized through libpayload, which is the C library. Really simple C library, but still it's not complete, but it has a lot of functionality. If you have a simple C application, you can just link with libpayload using the wrappers. We have some wrappers in the package. You run LP GCC instead of GCC. Out comes a payload binary instead of your normal ELF user space application. And we even have a curses implementation, which is pretty nice in libpayload. So you can have a nice user interface as well. I mentioned some auxiliary tools. We have Buildrom, which is important because, so we have coreboot, we have several versions of coreboot. We have a whole bunch of payloads. The payloads need to be configured. Coreboot needs to be configured. Depends on which mainboard you have. This can get a bit tricky. But Buildrom will take care of most of that for you. You just have to say, I have this mainboard, this flash chip, I want this payload, and go. Buildrom will gather everything up and build you the final working ROM file that you need to flash into your chip. Make elf image is, at the moment, the key tool for turning a Linux kernel into a payload. Just needs to add a little bit of glue. We have NVRAM tool that is used to peek and poke at bits in the 256 bytes of NVRAM that is in every PC. Good for storing boot time settings and passwords maybe, or maybe not. SuperIO tool, great for peeking poking at the SuperIO chip, which is the piece of hardware that implements all the old school ports like PS2 keyboard, parallel ports, serial ports. What else? Yeah, GPIOs if you have any. Intel tool and MSR tool, they're more complex register dumping tools, tweaking tools for finding out state in a system before you have core boot and after you have core boot, or while you're working on developing core boot to see what you're doing wrong. And we have a special tool called FlashROM, which I do some work on, and I like it a lot. It's a BIOS upgrade tool for Linux, or BSD, or Mac OS X, or Solaris. So you don't have to reboot using this sad old DOS floppy that doesn't work anymore in order to upgrade your BIOS. You can just do it from Linux. FlashROM also supports cross-flashing, which is an important feature. The DOS utility, it often checks that, okay, you want to flash this image onto this mainboard, but I don't know, this doesn't look like a match. I don't think you're going to be allowed to do this. You might end up bricking your board. This has a real sour taste, I think. So we don't limit the users in that kind of a way. If you want to flash a bitmap into your boot flash, that's fine. But please make a backup first. Seriously though, it's a really, really good feature, because if you do flash a bitmap into your boot chip, you can still yank the chip out, put it into another machine while the other machine is running, and run FlashROM to reprogram the contents, restore the contents of your flash chip and get the first machine booting again. FlashROM supports a whole bunch of flash chips, hundreds, 66 something chipsets, and more than 25 mainboards with small variations. A lot of mainboard manufacturers, they start from a reference design from the chipset manufacturer, and then they make small tweaks. So if we make FlashROM work on one of them, it will work on all of them. And there's this neat idea called push-pin flash. I so wish that I had come up with this. So these flash chips, they're can be a bit tiny. They're maybe 2 by 2 centimeters or so. And if you have a whole bunch of them, it can be tricky to keep track of them, and you need tools for pulling them out, and it's not always easy to get them in to the socket correctly. So take a thumbtack, pull out the pin, and glue the plastic knob on top of the flash chip, and you have a nice handle, and you can color code. It's pure genius. So demo time. I'm going to show you Core Boot version 3 running on an Alex 1C CPU board. That's an AMD Geode LX CPU. It's a PC system with an AMD CPU, 256 megabytes of RAM, made by a Swiss company. Pretty nice hardware. Let's see. So looking at the output here, we have a serial console, and I release reset now. We see Core Boot starting up, and it finds the Linux kernel. The Linux kernel is starting now, and we're up. Yes, it worked. You want to see it again? No. Okay. So this second demo is a bit more, has a bit more eye candy, and I'm actually going to move this over now. I tested this earlier today, so it should hopefully still work. Come on, don't be a hater. Oops. Okay. So apparently I can't really turn. Yeah, okay, I can turn. So this is Bayou, payload chooser, and into this Bayou I've built 3 different payloads. System information is core info. Yeah, okay, not perfect image. We're missing a top row. We see the CPU here. It's made by AMD. It's the Geode. Some CPU flags. We can look at the PCI devices and the config-based registers. great for debugging, checking out that core boot set it up correctly. We have the NVRAM to look at the settings. It's just hex, but still better than nothing. And the core boot information. We can see here this is the PC Engine's LX1C, and this is running a core boot version 2 that I built back in September. So we're done with that. We see that everything is configured correctly. We get a small reward. And when we're done playing Tetris, let's go back to here and see if we can boot the kernel, and we're up again. So, yeah, demo. Okay, what about security? Are there any issues with this, or are there any issues during boot that we should be aware of? Jake Applebaum had a great talk just before me up in Saarland about cold boot attacks, where if you didn't see it, the idea is to extract data from RAM chips even though you powered the machine off, and this works. What can we do to facilitate this attack in core boot? Well, because we're doing the RAM initialization, we can stop right after RAM initialization is complete and do whatever we want. It's open source, so go ahead and have some fun. Do some special dump routines. We can even utilize another trick, which is called cache as RAM, to not have to use any RAM at all, so we can really extract every single byte of data that is in RAM. Thanks to the system management mode, we can do TPM emulation or TPM sharing. So you want to listen to some music, and it's all locked up in this fruit box in the corner. You can sort of export that TPM in the corner and have that accessible over the network so that all your machines are able to play the music, for example. Or you can do an SMM rootkit, which I think Ben Kurtz is going to talk about tomorrow. Remote disks fan fun because, well, system management mode, you have full control. You could, for example, start using the CPU fans as a waveform output to play sound. If you think that's fun. And you can, of course, lock the user out to some degree and force them to play Tint until they win before they're allowed to start their system. And, okay, what can we do about this on the defense side? Because, of course, we can use it for defense as well. Because, precisely because we're controlling the RAM configuration, we can ensure that memory is scrubbed immediately upon boot, as soon as the memory is initialized. And if we're using ACPI also, we can make sure that the RAM is scrubbed before shutting down. Even better. We could do intrusion detection if there's an available signal, electrical signal, a pin somewhere that we can read, and if someone opens the case, well, we scrub the memory and feel pretty good about ourselves. Filter ACPI, make sure that the ACPI code that comes from the BIOS vendor and is running outside the operating system security model doesn't do stuff that we don't want to do because we're in control, really. Access controls require certain hard drives or other peripherals to be present with certain serial numbers before booting is allowed. Virtualization, to some degree, encrypts data on the fly and make sure that the flash chip is locked down. So, conclusion. Good stuff about core boot. We get a pretty quick, snappy startup time. That's nice. We all want that. It's open source as opposed to the two commercial BIOS vendors. Coreboot itself is licensed GPL, whereas the lib payload is BSD licensed.